that nutcracker and discuss this case study itself at that event. So Daniel from Prime, we are a head contractor, and we're doing a little bit in the green concrete space. Most of our work is in the industrial space. So today we're just presenting on a case study we did in the industrial flooring. Our trial partners for this case study was Griffiths Engineers Australia, with the structural engineers, and I guess specified the mixed design. We had High Tech, which is an Adbury company, supply the concrete, and Conspec place it. So the problem that we have in the industrial space really is that the industrial asset class has limited options in what we can do to attempt to decarbonise, right? Let me just get rid of that. So you can see that, you know, anywhere from, you know, 2/3 of the building is concrete and steel. And there's two things around that. There's performance of the requirements of the industrial building and performance of those materials in terms of large spans and whatnot. And if you look at an industrial building, essentially it is a high performance concrete slab and a garden shed over the top of it, if we really simplify it, right? A lot of engineering and a lot of operational issues around this slab and maintenance issues over long term and performance issues all sit within the slab. So that's where everything lands. So if you look at the embodied carbon GBCA targets that we've got, and at the moment it's 20%. It's 20% for all registrations next year, 40% for 6-star, and 2030 it all goes to 40%. So that's what really drove this case study for me, was trying to find an outcome of how do we get an industrial building, how do we get 40% of carbon out in the industrial building, which is a bit of a stretch target. And we're doing some other stuff with timber that I recently published, which shows that it's you know, close to impossible with our current materials. So, and keep in mind that in our industry, especially on the builders side, we're pretty archaic. We're pretty slow to innovate and uptake any new technology. And you know, one of my phrases is the fact that we're still building with bricks, which is what we built the pyramids with all those years ago, right? So as a builder, we don't want to use new materials. And it comes back to the conversation some of us were having earlier in that earlier presentation around risk and trialling new things, because the risk of trialling a new material as a head contractor is that if it doesn't work, I'm replacing that. So in the current environment, we have the big institutional clients and a lot of clients pushing reduced carbon products and buildings, but the builder copping the entire risk of that. Which brings me to the point that in the past 2 decades, we've been pouring these industrial warehouse floors with special mixers, where in actual fact, we've been reducing the SCMs and pulling the SCMs out and increasing our cement content to guarantee performance. And in actual fact, some of the institutional briefs still out there in the market cap your maximum SCM content of 20% and won't let you go over that, even though they're after a Green Star rating, which needs, you know, 20% on the overall building. And coming back to this pie chart showing that, you know, there's not many levers to pull. So you really need to pull more than 20% out of your concrete to cover the other elements. As for the industrial floor itself, yeah, we've refined this process over the last 2 decades, as I said, and we've rolled out thousands and thousands and thousands of square meters, and we've got it to a pretty fine art. I'll just play this little video while I keep talking about it. For those that aren't familiar with the industrial floors that we're doing, the slabs are generally anywhere from 160 mil to 180 mil thick, pending low case or ground conditions. They're traditionally fibre reinforced. The only mesh you just saw was around the door thresholds, but they are just fibre. We burnish them They're typically a 30 by 30 concrete panel with armoured joints, and we pour it off the chute and we use a laser screed Samero. We've been using green concretes externally in our external mixers, and you can get them off the shelf. We've been using green concrete in our office slabs, in some of our footings over the last couple of years. But our issue in carbon reduced on the warehouse slab is really the burnishing process, where that differs to any other concrete mix out there. So what we ended up doing in this trial, in this checkerboard over here, we had a freezer, and with a freezer you need a base slab that gets buried. So on this particular job, there was no requirement for carbon reductions. There was no requirement for Green Star ratings. We just did that off our bat to try and come up with a solution or at least trial. So we took our opportunity to trial a green mix. So the first day we poured a green concrete and then our traditional warehouse floor mix. And the next day we swapped it round so we could really have that control and see how they behaved from a placement standpoint. So we did that September 23. There's 1,400 squares there. We waited our 56 days. We did our crush test. We did our abrasion test to make sure that was all sound, and that passed. So in doing that, we were happy with the results. That we then, the next part was to go and pour 3,500 square metres of finished product and burnish that with what was badged Futurecrete by High Tech Concrete. So we used the high blend cement with SCMs, fly ash and WG5b FS, and we had a look at approximately 52% cement replacement on that. So what that ended up doing from the GBCA reference case was a 41% reduction. 6% of that was in the fibre and slab thickness from the reference case. The other circa 35% come from the concrete mix alone. Previous to this, we've heard of a couple of trials in the industry that weren't finished products, but that had issues with finishing on the burnishing, had some delamination, and yeah, it weren't successful. So this, to our knowledge, was the first successful finished product placed in the industry in industrial flooring. So in terms of the results, the green concrete trial, you see that we track circa 7 days behind the traditional mix. So that's really important in industrial warehouses, given that the programs are extremely, extremely tight, and that delayed strength gain stops your client or tenant getting onto there and putting their racking up and playing on. So that's just a little program consideration. But as for the abrasion testing, you can see these are two next to each other. They're all but identical and compliant with an AR05. So yeah, happy with that. So considerations moving forward, and I guess lessons learned is that it for the industrial flooring, it would need to be a bespoke mix and not what some of the suppliers, off the shelf mixes. You've really got to have either a concrete technologist or a industrial engineer really look at the mix in detail because of that finishing process. Additional time on program for the curing, affecting the early access, as I mentioned. Increasing in QA procedures due to the lack of tolerance. So this is a really, really important point in that, when concrete wagons are coming to site, water should never be added. But in reality, with what gets built and how things happen, sometimes water does get added. The traditional mix has a lot more cement content, so it has a bit more tolerance if water was to be added. The SCMs react a lot differently to the water, whereby if water is added, the delayed strength gain would be a lot more than the 7 days. So your QA protocols on site have to be super, super tight to make sure that no water is added. More all-season trials need to be conducted. So we poured between September to November type thing in 1 year. The traditional mix has 20 years plus of trials across all seasons, all weather types. So we've got enough data to be agile enough to and comfortable and confident enough to roll that sort of stuff out, where we've only done 3,500 here in a single season. So a lot more trial before, I guess, industry adopts it. And coming back to this, the shared risk profile between the developers and the contractors, because I think this is the main risk. So, or the main key for this to move forward. I mean, we've done 3,500 and that was off our own bat. If that went wrong, it's pretty expensive for me to go and pull all that up and put back a conventional mix. But some of these sheds are 20, 30, 40, 50, 60,000 square metres. So a lot of risk for the builder to roll this out. If it does go wrong, they're pulling it up. It's a massive, massive cost. And the developers at this point don't seem to want to share that risk profile. They seem to want to push it back down to the builder. And the builder, with not many of us doing it or having enough examples in the market, they're a bit tentative to adopt it. And so, yeah, the case study was published in the Green Review magazine. Mekla did a little bit of a case study and I discussed it at the Nutcracker. And that's it for the case study. My tech engineer isn't on the call. And so, if there's any questions that are full, concrete, nerdy, I'll have to take it on notice and take it back to him. But I'll answer what I can if we've got time, Evan.
Yeah, that was great, mate. Great case study, I guess, and great